Assalamu alaikum, welcome back everyone to Creative Multimedia Technology, and we are still in graphics in education, and this is part 3. Today we are going to talk about the format of the images. In the previous video we have talked about the differences between bitmap and vector, and today we are going to talk about the quality. Okay, digital graphics quality. As for your information, there are many factors that affect image quality, and we have discussed about the type of the camera, the size of the image, but there are two main factors that determine graphics quality, which are the resolution of the image and the color depth of the image. Now, what is the resolution? The resolution is, in another word, is the quality. How to measure this quality? By improving the resolution of the image. How to do that? By increasing the number of pixels per 1 inch. Alright? Now for the color depth refers to the number of distinct colors in one image, and one image can contain how many distinct colors in one image. So the image quality, rather than the resolution and the color depth, it also depends on the equipment itself. For example, the type of the camera. As I mentioned, there are professional cameras, and there are, the cheap cameras, the type of the lens itself. So all these factors affect the quality and the resolution of the image. So in this slides we are going to talk about these two main factors, which are color depth and the resolution. Let's start with the first one, which is the color depth. Now, how do we actually measure the color depth of any image? We can measure the color depth of an image by knowing how many colors in one pixel. Each pixel can be in a specific color, and each pixel consists of 2 or more colors. The more colors it has, the more quality the image will be. Okay, so the range of these colors is actually known as the color depth or bit depth or color resolution. So as much as it has more color, the image quality will be higher. Now the color depth determined by how much data in one bit. Okay, and this is actually used to determine the number of colors in the image as a total, but in one pixel how many colors depth, and in a total for the total image, the whole image, how many colors in one pixel. So the color depth is actually measured in bits per pixel. So always remember, a bit, which is a binary digit, is actually either 1 or 0, and there are 8 bits in a byte. We will get to know more about these details when we go further in these slides. Now, the greater the color depth, the more colors it may store, and this is also determines how many different colors the image or device may have or may contain to display. For example, for 1 bit we only have 2 colors. We will see an example for images with 1 bit, images with 8 bits, 16 bits, and so on. So in 1 bit, always remember, only 2 colors, so the quality is not going to be high. 8 bits, 256 colors, 16-bit, 65,000, etc. Right? And if you can see 32 bits, it has millions plus extra information. So the 32 bits, it has a lot of colors, millions of colors, which means the image quality is going to be very high. All right, and the size as well is going to be high. And this table right here explains about the color depth in each image. For example, if we have the color depth 1 bit only, so the bit per pixel will be 1. All right, so the range of colors only 2 colors. While on the other hand, if you can see 24 bits, it has 24 bit per 1 pixel. The range of colors is going to be above a million. Okay, so the image is going to be very high in quality and very high in size as well. Okay, so these are two images. It's actually the same image, but one with 8-bit and one with 4-bit. If you can see here, the one with 4-bit is actually lower in quality. You can see the dots, the pixels in the image. Now when we talk about image quality, you must know something called dithering. Dithering is actually defines the quality of the images. How? Now let's say when an image with millions of color is converted to an image with only 256 colors, some colors are going to be removed from the image. This process is known as dithering. So it's a process of converting a very high quality image to less quality. Okay, so an image with millions of colors, we convert it to 256 colors. It's called dithering. Now this process is actually like repositioning for different colors, pixels side by side, to create the illusion of some missing colors. And here happens the let's say blurring or the different in the quality. If you can see, this is an example. The first image, it's actually higher in quality. When we convert it to only 256 colors, this is what happens. It's like converting the image to less quality with more like pixels. Now this is another example. This is the original full photo, all right, and this is the dithered 256 colors. If you can see behind the bird right here, you can tell there is actually a low quality. You can see the pixels, the squares. All right, now let's talk about the resolution. Now for the computer resolutions, it actually determined by the number of pixels contained on a display monitor, with the LCD, the monitor of the laptop, and so on, which actually expressed in terms of the number of pixels on the horizontal axis and the number of the vertical axis. Okay, so the sum of the horizontal and the vertical axis. So the image resolution is actually defined as the number of pixels contained in a digital image. How many pixels in this image? This is what we call the resolution. Resolution is how many pixels in a digital image. And it also refers to the amount of information stored for each image. Now the amount of information stored is actually the same meaning as the number of pixels contained in a digital image. The same meaning. The resolution usually written as a product of the image dimension, the height, okay, of the image. Okay, for example, we have some images 320 multiplied to 200. We have a very good quality 1024, 768, and so on. And the resolution also can be refers to the total dots in one image, or one per inch. So this is what we call DPI, or pixel per inch, DPI. You must understand the meaning of DPI. Refers to pixel per inch, okay, in every single inch on that image. Example, one image can have a resolution of 72 dpi or 100 dpi, 1200 dpi or more. So the more dpi, the more quality, the more resolution, the more the size as well. Now, what is the difference between resolution and quality? It has a direct effect on the amount of detail that a digital image captures. So the higher of the resolution, the more pixels of the image. The more pixels, the sharper the images looks. So the higher the resolution, the higher the quality. Okay? If we have a very good resolution, we will have a good quality, and the size is going to be high as well. Okay, so the higher the resolution, the more detail in the image, very clear when we display it. The higher the resolution, the greater the demands for both storage and processing. This is actually important when you work in the graphic design business. You are going to need a very good actually hardware, memory, all right, very advanced laptop to be able to work with a high resolution, high quality images, because you are going to need more memory storage to actually save your work. Now, when we actually work on for example, a graphic design, when we work for a poster, a website, when we want to design a website, we must know that the monitors that we actually deal with, laptops, PCs, and so on, they have a limit of 72 pixels per inch. Now, if the PPI is more than 72, it's not going to be a big of a difference, because this is the limit of the screen that we actually dealing with. If you can see, this is a 72 ppi and 150 ppi is actually the same. Now, the resolution of any image tells you how small and densely packed the pixels are, and it tells you how many pixels do you have per inch. This is our the same example that we have. 72 ppi is the biggest ppi that we could have. Now we have 36. You can tell the image started to be blurry. When we talk about 18 ppi, this is a very, very low. We cannot actually tell the details of the image. So 72 dpi is suitable for electronic presentation. Now when we talk about 72 dpi, it's only for computers and PCs. But if you want to print the image out, you are going to need more dpi. Let's see, for you are going to need like 150 or 300 sometimes if you want to print, large advertisements, large posters, and so on. So using too low a resolution for a printed image, the results are going to be very, very low. You are going to tell about the pixelation. You are going to see the image as it is actually contains of squares. All right, so you need to be sure when you are dealing with printed materials, the DPI needs to be higher. Using too high resolution, pixels smaller than the output device can produce or increase the file size and slows the printing of the image. So always go with the precise image dimensions. If you want to print an A4 image, make sure to select the right size, the right dimensions. Always the higher the image resolution, the greater the file size. So it has a relationship between the image resolution and the size as well. When the resolution is high, the size of the image is going to be high as well. Okay, in these slides we have learned about the quality, about the resolutions, how we can tell about the quality of the image, what is the resolution means, the color depth, and so on. And I will see you in the final part of graphics before we go to our practical course next week.